Good morning, children. We're out here this morning to talk about a very serious topic. The devil. Now, as you know, the devil comes to you in many and varied forms. However, in level 2 physics, there are two particularly nefarious forms that you have to be aware of. Speed equals distance over time. Acceleration is change in speed over change in time. Both of those equations are work of the devil. They're going to tempt you into incorrect answers. They're oversimplifying the situation. And so, speed equals distance over time only works when the speed itself is constant. However, in level 2 physics, we are frequently dealing with acceleration, changing speed, and so that equation will frequently give you the wrong answer. Acceleration is change in speed over change in time. It's just an oversimplification of another equation that we're going to look at now. You never need to use it. I don't know why it's included. We're going to look at all that is good and true and beautiful. And that is kinematic equations. So the kinematic equations, of which there are 4, and which all 4 are published for you on your formula sheet, they are the force of good in level 2 physics. They will always give you the correct answer. However, they're more complicated, as you can see, than our oversimplifications here. A few things we need to know. We've got a VF and a VI. We know that V is velocity. We're wondering what VF and VI might be. Well, these equations deal with objects that are changing velocity. So VF is the final velocity after the change has occurred, and VI is the initial velocity before that change has occurred, and both of those are measured in meters per second. The A is the acceleration, which is measured in meters per second squared. T is time, measured in seconds, and D is the distance travelled, measured in meters. Now the tricky thing with these equations is you'll notice that there are 4 of them, and we're thinking, what kind of situation might we need to use them in? Well, you'll notice that all of them emit one quantity. Like this first equation here, there's no D in it, and so you'd use that in a situation where you don't know D and you're not trying to find D. In the second one, there's no T. Use it in a situation where you're not trying to find T and you don't know T. This third one here is particularly complicated. It works really well when VI is 0, when you're starting from 0 speed. Otherwise, you've got a T squared and a T, which makes it a quadratic if you're trying to rearrange it for T, and so it's awful. So only use that one for T equals when the VI is 0, but you can see it's got no VF in it. And this one down here, no A. And so all of them have their own place where we can use them, and we just match them to the situation that we're trying to solve. Let's have a look at a situation. So, here's an example. Say we get our spiky-tailed friend and put him in a frictionless mining truck and roll him down a hill 20 meters long. As he rolls down the hill, there's an acceleration of 1 meter per second, and what we want to know is just how long is it until our spiky-tailed friend gets to the bottom of the hill, assuming that he starts from rest. And so I want you to pause the video and have a go at using those kinematic equations to solve this problem. Pause it now. Okay, so problem solving technique is we're going to start by identifying what quantities we already know. A is 1 metre per second squared. D is 20 metres. There's a clue in the writing. Starting from rest, that means VI is 0. And how long to reach the bottom? The T is what we're trying to find. So we need an equation that's got a T, a VI, a D, and an A. No VF involved at all. Did you get that one? D equals VIT plus half AT squared. And the first thing we notice is that VI is 0. And so 0 times T is nothing. We can cancel out that first term in the equation and just rewrite it. And we're trying to find time. We're going to rearrange that to find T. We're going to start by getting rid of the half. How do you get rid of a half? You double it. We need to get rid of the A next. How do you get rid of times by A? Divide by A. And finally, we don't want T squared. We want T. How do you get rid of the squared? You got a square root. So you should have got an equation of T equals square root of 2D over A. Plug some numbers in. Hopefully you got a time, 6.3 seconds. Let's get on to some practice, shall we?